Write the product of the transformation, that is product of the reaction, and the set of reaction consisting of reagents and the step C is provided for us as here. That reaction is associated with the reagents and the reactants are benzene followed by exocycline, exocyclohexene followed by HF. Whereas in this reaction, our unsaturated system, that is exocyclohexene, on reaction with the acid, that is some amount of H plus, some amount of F minus is present in the HF. H plus, as being it is electrophile and this alkene system is electron excess, initiates the reaction. As a result, it is converted to corresponding relatively stabilized cation, that is secondary. This is primary, whereas this is what? Tertiary. Tertiary carbocation is relatively stabilized. It results into the formation of the relatively most stabilized carbocation. Such of carbocation formation takes place. After formation of this stabilized carbocation, this behaves as a new electrophile. Now still now our H plus is electrophile. Now this H plus place is got replaced by the new electrophile, that is this particular methyl substituted cyclohexene is the electrophile. Now it makes an attack over the benzene system. Thus the net reaction related to the transformation appears as benzene followed by, this is our cationic system, tertiary carbocation as electrophile makes an attack over the benzene system electrophilically. Electrophilic substitution takes place followed by hydrogen replacement also occurs from the place where electrophilically it got substituted. As we know, it is a 6-membered ring system. This is 6-membered ring system having methyl over here. Such of substitution takes place. So therefore this is the spot where it got connected. It is a tertiary carbon. Tertiary is the stablest. Thus the final product of the transformation is this one. Once again, I am writing the formed final product in the box. This is the final product of the transformation. If we go for the justification of the set of reactions, those occurred in the case of this particular reaction is, here whatever the exocyclic cyclohexene is there, this on reaction with the HF, as being HF is a weak acid, that H plus makes an attack in such a way that it results into the formation of stablest possible relative stablest carbocation, that is tertiary carbocation formation takes place. This tertiary carbocation as electrophile makes a substitution over the benzene system that results into the formation of such of final product formation takes place. Write the product of following sequence of reactions, and the set of reactions are given by ethyl benzene on reaction with a set of reactions, that is bromine followed by ferrous. Second one is chlorine followed by HNO, and third one is alcoholic potassium hydroxide. A combination of these three things are happened over the benzene system. We are asked to write the final transformation. Yes, the zigzag form and the corresponding sequence of reactions can be given by, I can write ethyl at any spot. So all are same. Here I am writing ethyl. This is CH2 followed by this is what? CH3. Whereas this was subjected for A reaction conditions. A stands for what here? Bromine followed by ferrous. Ferrous is a Lewis acid. So in the presence of ferrous, this bromine is converted as Br plus, that is Br is electrophile. So therefore electrophilic substitution reaction takes place. Whereas that electrophilic substitution reaction occurs at its ortho and para positions. So therefore this particular ethyl group is ortho para directing group. So there are two possible positions. One is at this place, one is at this place. We will be getting mixture, but this place is more preferable because here less strain is present in the product. Product is associated with less strain because these two groups present on the benzene system are present far away from one another. This is the result of the first reagent, that is A. After this we are going for the B. B is chlorine followed by HNO. Chlorine in presence of sunlight conditions is converted as chlorine radical. So the sunlight is utilized for the cleavage of chlorine-chlorine sigma bond. As a result, here chlorine radical is generated. Moreover, under this particular HNU conditions, here also radical is getting generated. That is, radical substitution occurs over here at the allylic position or the benzylic positions. That possible allylic and benzylic position is this particular place. This is allylic. Here radical is generated. That becomes more stable. Hence here chlorination occurs. This is the place where chlorination, as being it is allylic, as being it is benzylic, chlorination occurs over here. After this, if I perform the alcoholic potassium hydroxide is a strong base. In presence of this strong base, elimination of acid takes place. Here the possible acid is from here hydrogen, from here chlorine. That is, this is step C, whereas in this step, elimination of HCl takes place. As a result of elimination of H and Cl, anti-elimination, SN2 elimination or SN1 elimination results into the formation of here double bond system followed by bromine formation takes place at its para position as major product. Once again, if we go for the set of reactions that we performed over here, this is ethyl benzene. Ethyl benzene is subjected for the free radical, subjected for the electrophilic bromination because this is acting as Lewis acid, Br plus is generated. So electrophilically Br preferentially as major product substitutes at the para position. Then after, on reaction with chlorine followed by HNU, chlorine radical substitution occurs at the allylic position. Then after, on heating in presence of alcoholic potassium hydroxide, which is a strong base, elimination takes place. That elimination is generally SN2 elimination, otherwise E2 elimination, results into the formation of what? Our ethene system as a substitution takes place over the benzene associated with the bromine at the para position. Thus, this will be the final product, including the corresponding reagent related transformations in sequence.